Okay, so looking at number 13 on your homework on 8.3, and there is such an easier way to do this than what they're having you do here. They haven't told you anything about the equations of lines, so there's a real fast way to get the slope here. For instance, on 13, I'm going to show you how you could know for sure what it is. In the next section, I'm just going to go ahead and introduce you to this. If I label this, since it's solved for y, if I label it mx plus b, I can know my slope is 2 here. They're trying to, before they introduce this to you, get you to figure out by getting you to find some points on the graph. So let me get a little table going here. Let me pick some x's and plug them in. I don't actually have to draw a graph, I guess. I'll graph it as I go, though. If I have, let's say I plug in x is 0. Then 2 times 0 is 0, plus 1 would be 1. So I've got the point 0, 1 here. So let me put a little dot there. Maybe I pick another easy point, like 1. If I plug in 1, 2 times 1 is 2, plus 1 is 2. So I've got, oh wait, no, so 2 times 1 is 2, plus 1 is actually 3, isn't it? Sorry, it's the end of the day, and I am pooped. Okay, so at x is 1, I'm going to go up 2, 3. 1, 2, 3. I'd have a point here at 1, 3. Now I don't have to graph it. I could graph it and I could count it off. That's one option. Just put the graphs on a graph that's got good numbering, grids on it, and count it off. But what I could do here is, if you remember what we talked about, is that we could take these points and put them in a table. They're in a table there, but let me make a cleaner table, okay? If I put 0, 1 and 1, 1, no, 1, 3, I keep getting that wrong. 1, 3 is the point. 3 goes, if x is 1, y is 3. So what is if you remember, your slope is your change in y, or you subtract your y's on top, and then you subtract your x's on bottom. So if I'm going from 1 to 3, from 1 to 3 is a plus 2. So this is my change in y here. It's the plus 2. If I go over on the other side and I look for what happens on my change in my y's, from 0 to 1 is plus 1. I get 2 over 1, which is 2. I could use the slope formula to find it also. We'll go through that just in case you want to do that, because you should be able to get, the same answer no matter how you do this. If they're counting it off up here, it would be up 2 over 1, so it would still be 2, because up 2 and then over 1 would be 2 over 1. If I were counting it off the graph. If I were using the slope formula, let me just plug these in here just to show you that we're going to get the same answer. Maybe I'll label this one x1, and this is the y1, and this was my x2, and here's my y2. So if I put my little parentheses in, so that I make sure I don't mess up with these subtraction signs, y2 was this 3 over here, and y1 was 1. x2 was 1, x1 was 0. I'm just using the labeling I did up there in this little green table. 3 minus 1 is 2 on top, 1 minus 0 is 1 on bottom, 2 over 1 is 2. So no matter whether I pick it off the equation, I get 2. I could graph it and get 2. I could use a table and get 2. Or I could use the slope formula and get 2. I'm always getting the same answer. Let's look at number 15. 15 says y equal 8 minus 2x. I'm going to go ahead again and just talk about all the different ways we could do this. First of all, when I write functions, I always want to put the x term first, and since there's a minus sign in front of that 2x, it's the same thing as saying negative 2x plus 8. Remember, I could have thought of this as 8 plus negative 2x. You could see how you could switch it around and get negative 2x plus 8. Now, in the next section, they're going to tell us, hey, label this mx plus b. Oh, my slope is negative 2. So, again, we're going to have a real easy way to get this in the next section, but let's say I don't have that yet. I could go get some points and graph them, or I could use a table, or I could use a formula. Lots of ways to do this. Let's just make a little table really quickly. Let's say that I plug in 0. 8 minus 2 times 0 is going to be 8 minus 0 is 8. So I've got the point 0, 8. And let's say I plug in 1. Just picking some easy points to plug in because I don't want to work too hard, right? 8 minus 2 times 1 is 8 minus 2, which is 6. So I've got the point. If I plug in 1, I get, if x is 1, y is 6. All right. So, again, I could go graph it and count it off. I'm not going to do that just because it takes so long to do on an iPad, and it's really kind of hard to count off anyway without a really nice grid. So I'm just going to look at the other ways. if you look at this, if these are my x's and these are my y's, now I could make a little table out of it, and I could say, well, my slope is the change in the y's over the change in the x's. Well, how much did my y's change? I went from 8 to 6. Hey, they subtracted 2 there, right? And if I go on the x side over here, I'll do that in green, from 0 to 1 is add 1. Negative 2 over positive 1 is negative 2. There's my slope, and notice it's matching this number in front of the x there. Now if I use my slope formula, I'm just going to take those same 2 points, 0, 8, and 1, 6, and let's label them to use the slope formula. Let me call this x1, and this is y1, and I'll call this one x2, and I'll call this one y2. My slope is y2 minus y1 over x2 minus x1, and I could put parentheses in so I can plug them in and make sure I don't mess up anything. My y2 comes first, that's the 6, and I'm supposed to subtract y1. y1 is 8. On the bottom, x2 is 1 and x1 is 0. Okay, so 6 minus 8 is negative 2, and on the bottom 1 minus 0 is 1, and negative 2 over 1 is negative 2. So again, this is using the formula. Over here I just used the idea of the tables and kind of stacking the points, and that the slope is actually how much the y's change over how much the x's change. I kind of thinking a little more informally there, but just using a table to do my subtraction. And again, we're going to get this formula in the next section, and all we're going to do is look in front of the x term, and ta-da, there's our slope. So that's kind of good to know that it's kind of nice to point that out here, that you can see it all matching up.